Three methods in 5.7. We're going to talk about two of them today. We're going to start with trig power integrals. And I tend to keep everything as sines and cosines. Okay, so when I give you the Shams, you'll see some tangent and secant problems, right? So we're kind of talking about sines and cosines together because they have the relationship of derivative or integral, right? Same thing with tangents and secant squareds or secants and secant tangents. But I like to simplify things a little bit. I will keep it only to sines and cosines. Okay. So in the book, if I give you problems 1 through 20 and some of them aren't sines and cosine problems, you can skip them. I'm right. I'm just trying to cut some of the material out. So, but when I'm talking about these trig power integrals, I'm talking about some kind of integral of sine to the mth power and cosine to the nth power dx, where m and n typically belong to zero, to the non-negative integers, right? And I tend to not go past the third power. So it could keep going fourth power, fifth power, sixth power, and it's ridiculous, right? It's just, but once you get the few tricks, they're all easy. They just get, the problems get longer and longer and longer, right? I'm trying to have no problem be more than 3 pages for you. Right, when you're writing up the midterm solutions, you could have a problem will go 2 or 3 pages. Right? And so you just got to be organized and stay calm. And Chuck, what? Mutiny on the Bounty? What's going on? I don't have to. But you'll see. You'll practice. It's not a big deal. And why does it take more pages? Because you want to be organized. You don't want to try and squeeze things in, right? And then lose track of things. You want to try and have a nice complete thought somewhere, and then a nice complete thought somewhere, and then, right, and it's nicely spaced out, and so you could write little notes maybe, or you know, do some side work kind of thing. So for example here, so just for me to write an example, I could have something like sine squared x dx. So these are examples without me solving them, okay? So sine squared dx. So you can see that the value of m is 2 and the value of n is 0. So can you imagine any combination, right? So the integral of sine squared x cos cubed x dx, right? So you can imagine any combination of those powers, right? Do you get what I'm saying? Right? So it could be just cos cubed, right? So any non-negative integer power with a product of sine and cosine kind of thing is what we're talking about in this section. If I look at the book here, where is my book? Oh, here it is. If I look at the book here, this is 5.7. The homework we're talking about in this book is really just 1 to 9, with the last few being tangents and secants. Okay, so but we're talking here about MindTap 5.7, number 1 to 9. But this is why I'm giving you the Shams, because I don't think that's enough, right? I mean, you'll see that 1 through 6 is they're all similar, and those are all the sines and cosines. But so that's why I'm going to give you the Shams outline, because it'll give you a couple of other problems to try. Okay. So we've got two problem types here. I'm sorry, we've got probably three problem types here. And forgive me if I have to go back and say it's four. I can't quite remember off the top of my head. So the main problem types here are going to be power reduction, a singleton trig, meaning I want to kind of create a single sine function and everything else cosines, or a single cosine function and everything else sines, right? Rewrite, right? And then three is just, of course, a bunch of trig identities. So you're going to, and obviously the trig identities are Pythagoreans. So Pythagoreans are really the main thing here. So I don't know if these are all individual problem types. One or two of them could happen inside of one problem, but these are the things you're looking for, okay? So the power reduction will always be a trig to an even power. So power reduction is a trig to an even power. I'll show you that formula. A singleton trig is when you're trying to get things to turn into a single sine or a single cosine and then everything else. And then trig identities are obvious. You're going to use them many times, right? So let's do the singleton trig first. It's the easiest one. I know I'm not in order, but it doesn't matter. So for example, I'm going to use this singleton trig idea when I have odd powers. So odd powers of sine or cosine. So this one is obvious, right? Antiderivative of sine is what? Negative cos, right? But what if I have sine cubed? So the idea is when I have odd powers, try and separate a single trig. Try and free a single trig as a factor, right? And so this one is really obvious, yes? I got a sine squared times a sine, right? And so there's my singleton, right? That's what I'm calling it. I don't know if it's the right wording, but it's what I'm looking for, a single factor of sine or cosine. So now I'd like is to be a sine function times a cosine function. So I'm going to use my Pythagorean here, right? So sine squared is 1 minus cos squared of x, right? These are pretty easy, by the way. It's the next topic that's tough, okay? So these are pretty damn simple. And so now I'm going to distribute, right? So what do I get? An integral of sine of x minus the integral of sine x cos squared x. And both of these we've seen before. So here I am at trig powers, right? A level 12 or something and what should I try? Obviously, if you see trigs at a power, you're going right away to trig powers, right? So, but the first one we already know is opposite of cos of x. And the other one is we're going to let the singleton be the derivative. So u is going to be cos of x. Du is what? Derivative of cosine is what? Negative sine. So I've got plus the integral of u squared du. Make sure I'm not going too fast there, please. Make sure you're with me there.
Can we substitute from the top, like 1 minus cos x squared?
Well, then, so you're saying u is 1 minus cos squared?
No. From the top, like there is 1 minus cos squared x.
Yeah.
Right?
Yeah.
So assume u is cos x. So du is a sine x minus sine x, so we can take the...
Yes, I think that will work. I think that will work. Try it, Charlie, and see if you get the same result as me, okay?
Professor, how did we go from negative cos x dx to sine squared x sine x dx?
What line are you at?
Oh, never mind.
Okay. Okay.
Oh, wait. So you're saying that the first line is equivalent to the second line?
I'm sorry. First line was the first example.
Oh.
Right?
Mm-hmm.
And then the next line is the second example. So remember, I'm looking for
Oh,
odd powers.
okay.
Sine to the first, sine to the third, sine to the fifth, sine to the seventh.
Okay.
Right. So I just mixed two problems up together. Sorry.
Okay.
Yeah, so the second line is a new problem, sine cubed. So when I see trigs to odd powers, I want to try and peel off one of them, right? Factor off one of them. So I'm looking to create a single sine or a single cosine factor, and then manipulate the other piece. So what do I get here? I get minus cos of x plus u cubed over 3 plus c. And of course that u is cos, so I get cos cubed x over 3 minus cos of x plus c. So you'll see this singleton trig will happen quite a bit. This thing will happen quite often. So odd powers is almost every time like this, right? So I don't even know if I have 3 problem types, probably 2 problem types. Odd powers of trigs, even powers of trigs. Okay, so that's really what we're talking about. And the even powers are going to come from the power reduction. Okay, so let's move into that right away. Is this okay? Everyone all right here? So worst case scenario, I'd have something like sine cubed or cos cubed, right? And I think the shams will go higher than that. So don't torture yourself with the shams that are going higher than a power of 3. If it's a single trig like sine to the fourth or cos to the fourth, definitely try that one. Okay. But let's go to power reduction because this one's really easy. And once you do that one trig substitution, it's very simple. Distribute, solve it, right? Double check it with a derivative. And I'm glad these are easy because the trig substitution problems are not easy. That's what we're trying to. I don't know if the gods did this, the math gods did this on purpose, but it tends to go a really easy topic to a really difficult topic, to a really easy topic to a really nasty, horrible, difficult topic, and then a really easy so it is like, torture to kindness. So power reduction is the big one. So we have 2 formulas to memorize in our power reduction piece. And these are easy to prove. So these are going to be on our formula sheet. So sine squared of x is the same as 1 minus cos 2x over 2. and cos squared x is 1 plus cos 2x all over 2. So these are my power reduction formulas, right? So so you can see whenever I have an even trig power, this is a process I'm possibly going to use. We're going to be careful, but it usually will come into play. But don't be so anxious if you see, like if you see sine squared, cos squared, don't instantly change to this, right? You got to think a little bit first, okay? So for example, sine to the fourth would be sine squared squared, right? So that would be 1 minus cos 2x all over 2 quantity squared. And then FOIL it out, just like we're back in, right, algebra 1 or algebra 2 or whatever. And again, I will, in combination, I won't go past a power of 3. With a single trig, I would expect you to be able to do up to power 4. Okay. So these are pretty easy to prove. I don't know if you see where it comes from, but it comes from the cos of a double angle formula, right? So if we looked at just a single cos of 2 theta, right? Who remembers that main identity here? So this formula should be on your sheet, right? So the one I always remember is this is a cos squared theta minus sine squared theta. And so you can see now here in my two power reduction formulas, I've got a sine squared or a cos squared, right? So I'm just solving for one of these, and then I'm going to try and simplify as much as I can, right? So let's just do our cosine one. Let's just do this one. So I'm going to leave the cos squared theta on the right, and I'm going to move the sine squared theta to the left. And sine squared theta is by my Pythagorean identity is 1 minus cos squared, right? So I've got cos of 2 theta equals cos squared of theta equals cos of 2 theta plus 1 minus cos squared theta. And you can already see it. I'm going to move my cos squared theta to the other side, to the left side, so I'm going to have two of them. And then divide by the 2. And there's my power reduction. Really simple. So if you right, so let's pretend, oh Robert, I didn't put my power reduction formula on my formula sheet. Can you tell me what it is? And I will say to you, no, get away from me. It's a test, you punk. No, I say, can you remember the cos of 2 theta identity? And then you can derive them, right? But just put it on your formula sheet, please. All right, nice and simple, right? So let's go for it. Let's do cos squared of x dx. So if I didn't tell you power reduction here, what do you think is your choice? If I never told you power, am I okay to move on? Does anybody need time here?
Yeah, can I get a second?
Yes, Josh. Sorry about that.
Well, I'm good.
All right, nice, Josh. Thank you. So if I didn't tell you this was power reduction, what do you think is your process here? Here's my, so right under this line here, this last line I've written, I want to do the integral of cos squared. If it was cos cubed, we know what to do, right? If it was cos to the first, we know what to do. If it was cos to the fifth, we know what to do. We're going to leave off that singleton trig and then change using trig identities. Okay, but so now we're at an even power. And even powers, I want you to be thinking a power reduction. Okay? It cuts the power in half, so I can't use a power reduction with a cos cubed, but I can use it with a cos squared, a cos to the fourth, a cos to the sixth, right? And then sometimes I'm going to have even powers in combination with the other trig, right? So, but in this case, if I didn't tell you it was power reduction, what on your list of integration methods would you try? Eleanor, you got it for me? Yes, you do. Trust yourself. Think about what could possibly work here.
I would say power rule.
Okay, but the power rule, I'm saying you don't know yet. We're pretending. I might as well make myself a billionaire. So you don't know the power rule, and I'm a billionaire. All right, class is over. If we're gonna do hypotheticals.
We could separate it into two singletons.
Beautiful, but it's a product, right? And we just learned that what will undo a product rule for us? What method does
Integration by parts.
by parts exactly? So we're going to do this one twice today. We're going to do it once by parts, and we're going to do it once with power reduction. Let's do power reduction first because it's easier. It's the first choice. When I see a singleton trig to an even power, and again, remember, my thought is I'm going to restrict to sines and cosines. Let's see what happens with the power reduction. So this is now the integral of 1 plus cos of 2x all over 2 dx. And I've got it memorized, or I've got it on my formula sheet, right? Or both. So I get two integrals out of this, right? I get the integral of 1/2 dx. I'm just dividing and conquering, right? Plus 1/2 of the integral of cos of 2x dx. Don't let me go too fast here, right? I know Charlie's already done, but you can't slow that man down. He's a machine. He's a math machine. So the first integral is just half of x, right? And the second one, I need a u sub, right? So clearly there's an inside of u is 2x and du is 2 dx. So I need the 2 and I need to cancel it with a half. So I've got half of x plus 1/4 of cos of u du. And the antiderivative of cosine is sine, right? Nice. Anybody get there? Okay. I am going to put in a request that if your camera is off, that if you can post a picture of yourself, I'd like to kind of know what you look like before the exam, so you don't have someone else come in and take the exam for you. But you know, so can I show you my screen here? I might make you seasick here. Sorry about that. I'm going to move my camera so you can see what I can see. So I can see the whole class. You see that? So the cameras are at the top. People with the cameras, and there's a couple of students right now. Caleb and Ash has a profile picture up there, right? So I would like you. Sorry if I'm getting you seasick. This is my messy room. I'd like you to put a profile picture up there. I'll show you how to do that real quick. So I just when you go into Zoom, right? So when you go into Zoom, you go into montgomerycollege.zoom.us. If you don't go that way, this is the way in order to put a profile picture. So montgomerycollege.zoom.us, okay? And then you sign in with the same login as your Blackboard. Yes, you with me? And then you can just click on your profile up here on the top right. Oh yeah, click on my name, and then I can edit that picture. And so you just have to have a picture somewhere on your computer, right? And so once I do that, if I'm in my Zoom and I turn off my camera like I'm going to do right now, that profile picture shows. So I would like you all to have a profile picture up there. So when you turn your camera off, I can still kind of get the sense of, you know. And I tried at one point to change my picture every day. I was like, oh, this sucks. I'm not doing that. I wore the same thing every day anyway, so who would know if I changed my picture? All right, let's do the same problem, right? Let's do cos squared x, but let's do it by parts. Okay, this one's a little bit more difficult. So we're doing the integral of cos squared x dx by parts. So this is a little tricky, right? Well, I know I only have a trig, right? So, but the question is, do I let u be cos of x, or do I let it be cos squared of x, right? And I claim they both work, but one is a lot more difficult. So let's go with u as cos of x, and let's do by parts. On your mark, get set, go.
Would it not be cos squared x?
So I have choices, right? I could let u be cos of x. I could let u be cos squared x.
Oh, I see.
Yeah. But so if I pick u as cos of x, then v has to be the integral of cos of x, that leftover one. And I'm going to stop here for a second. See who gets there with me. Anybody get there? So what's the issue here now, Angel Nice? Well, so I'm saying I don't want to use power reduction. So this is a power reduction inside of here, or I got to do another by parts, right? Anybody not here yet? And I understand that there are times when, I'm sorry, I got a chat here. There are times
That
tonight.
was about the profile.
Oh, okay. Yeah, all right. Thank you. It might be that you have to be logged out tonight. It might be that. Go ahead, Chuck.
Can't you just change the sign on the right-hand side, the sine squared to 1 minus cosine squared? Instead of being the cosine squared over to the left side.
Nice. Okay, Chuck gave us the secret. The shorter way to do it is I'm going to use my trig identity here of 1 minus cos squared.
Right.
And then I'm going to have that loop, right? I'm going to have that loop that will allow me to move that cos squared integral to the left.
Mm-hmm.
So I'm going to have the integral of 1 dx minus the integral of cos squared x dx. Okay, so let me wait for everybody here. And I'll try and be better at. Okay, and you got to remember, let me know if I offend you. I should offend you a couple of times this semester, just because it's my nature. I'm offensive. I'm from New Jersey, but let me know if I do that. I don't want to do that. Like if I ask you if you need more time and you say it in the chat, and I say okay, okay, Angel, I'll give you more time. You didn't want anyone to know you needed more time. You know what I mean? I'm not trying to hurt anybody's feelings. I feel like we're all a team, right? And I'm the coach. I want us to win, right? And not every coach makes the right decision every time. You know that if you ever played on a sport team before. But so I'm going to move my cos squared to the other side so I get 2 of them. Sorry, cos x sine x plus c, right? Yes, you with me? Nice. Nice, that's Adam, right? Adamito, yes? So you can change your name right on your Zoom. If you're in Zoom, you can retype your name. But I know sometimes we have to borrow a computer or something. So now I divide by 2. I don't care about dividing the constant by 2, right? If I divide my constant by 2, then it's still a constant, and I just rename it c or k or whatever you want to do. So I get the integral of cos squared x dx is 1/2 of cos x sine x plus x over 2 plus c again. And it's almost what I had before, but what I do is I multiply this guy by 2 over 2. And so I get 1/4 of 2 sine x cos x plus x over 2 plus c. And the 2 sine x cos x is sine squared, right? Sorry, sine 2x. And that's what I had before. So all those trig identities from pre-cal you should, right, definitely have on your formula sheet. I like problems like that, where I tell you to solve this problem 2 different ways and verify that they're equal to each other. So that's a good question for a midterm. It typically hasn't happened in a couple of semesters because as we've gone to COVID and me proctoring over a camera and catching so many students cheating, I just started to shorten the test and make it more difficult, so it'd be very hard to cheat on it. And so it's a little bit unfair, but I think I make up for it with the 20% homework, 10% project, 5% extra credit. So I'm kind of expecting you to have that 25% perfect, and then it will make up for the difficult test. I do have students get A's on the test, so yes, they're difficult, but doesn't mean you can't do it. You just have to prepare the right way, and you have to practice.
Has anyone got 100?
Yes, I've had I had a couple of perfect scores. Every semester I usually do. I used to give out a $100 bill if you got a perfect score, but my Monopoly game was getting just beaten up pretty bad. So now I give one of the 4-color nerd pens. You know, the ones that you can switch the red, green, blue, black. I send you a nerd pen if you get a perfect score. And when you get it in the mail, I guess because of COVID, just let it sit there for a month, and then you can. That won't come from me directly; it'll come from Amazon. But
I have a question.
yes, Nima.
Why did you multiply by 2?
So I recognize I kind of have my sine 2 theta here, right? I know from sine 2 theta is 2 sine theta cos theta, right? I know that identity. So I just needed a 2 upstairs. But to get the 2 upstairs, I have to also have a 2 downstairs, right? I can only multiply by 1. So I multiply by 2 over 2. So now upstairs I get the 2 sine theta cos theta, which is sine 2 theta. And downstairs I get the 4, just like I had in the other solution when I did power reduction.
Okay, thank you.
Yep. You know, and it's probably been a while since we took trig and pre-cal. It could be a whole year now. It could be more. And then you could have had a teacher that didn't stress those identities, or didn't get to all the trig, right? So there's strike 2 or 3 already, and so you just gotta know what you're weak at and work on it. I really like, even though Khan Academy puts me asleep, I like his trig course. I don't think that's a bad thing to do. There's a lot of trig in this course. There's quite a bit of trig in linear, because the trig gives me rotations, right? So if I'm like programming how to get turbulence out of airplane wings, right? The airplane starts to go turbulent, and I need to get the balance back. I'm using trigs to rotate in any direction. So cosines are rotating like this, sines are rotating like this. Hopefully we don't have to use the z, because that's bad. That's a really bad rotation for a plane. And so in linear algebra and computer programming, we're using matrices and trigs to run things, robots, elevators, airplanes, etc. It's cool stuff. I can't wait for you to see it. It's awesome. Let's do one more, and then and please try this one on your own. Not the one I want you to try on your own. I want you to try. So this is a you try with a power reduction, right? So you try that one with the power reduction. It should be in the book and or in the shawms that I give you, but you try that over the weekend, okay? And the first step, of course, is to write it as a sine squared, all squared. All right, and the power reduction is going in there. Okay, let's do one more, and then we'll do our last piece. We might take a little break before the last piece because it's pretty tough. So, of course, if any time you need a break, you take a break, right? You don't have to. You don't have to let me know, and I'm recording, right? So if you miss something, And then you could always go back to the notes, or you could ask me to go back to the problem. Maybe you missed it and say, can I take a picture of the previous problem? And, you know, just talk to me. I'm pretty easygoing. I still want rigor. I want you to be able to do the work, but I'll help you till I pass out, you know. Okay, so let's do one more problem. This is the classic sine squared x, cos squared x. So I might want to just go right away to change into two power reductions. And I guess that would work. So that's one way to try it. Change both into a power reduction and distribute. And then see if you can do the integral, right? But for me, I gravitate to turning everything into sines or everything into cosines. And I don't particularly have a preference, but both methods will work here. And so you do the second one, right? You change the cosine squared into 1 minus sine squared and then distribute and see what happens. Because if I do that one, I'm going to do the problem I told you just to try. So I want to see what happens if I do both into a power reduction. So I have 1 minus cos of 2x all over 2 times 1 plus cos of 2x all over 2 dx. So I power reduce both of them. And you just don't have it memorized yet. It's okay. It's not a big deal. You will. Right? Now I like this. So I can bring out this 1/4, right? And then I have this my old favorite from Algebra 1, right? The difference of squares kind of thing. Or a plus b times a minus b. Conjugates, if you will. Right? And so I know the middle term is going to drop out. Yes, you with me? So I get 1 minus cos squared of 2x. Make sure you're with me there. Make sure you agree with all of that. I do my algebra fast. You don't have to. I drive fast too. You shouldn't. Right? So don't, just because I do things fast doesn't mean you should. Whenever I don't eat food for a day, I do it fast too. That's a joke. When I don't eat food for the day, I do it fast. So this is, everyone okay here? You agree with me here? Anybody need a moment? I'm looking at the chat, so you can always chat to me, and I'll keep my mouth shut if you need a moment. So I've got two integrals here, right? So I've got 1/4 of the integral of 1 dx minus 1/4 of the integral of cos squared 2x dx. And that, so the first one is easy, right? It's just x over 4. The second one is I need another power reduction, right? So I've got to reduce a cos squared. And then look what happens when I power reduce, though. When I power reduced cos squared the first time, what happened to the angle? It got doubled. So every time I power reduce, my angle doubles. So I'm going to get 1 plus cos of 4x all over 2 dx. So when I power reduce, my angle doubles. So the first time I have a cos squared of x, and then I got a cos of 2x inside of that. Now I have a cos squared of 2x, and now I'm going to have a 4x, cos of 4x inside my power reduction. And I'm just splitting, right? I'm just distributing, dividing and conquering kind of thing. So I have an x over 4 minus an x over 8 minus 1/8 of the integral of cos of 4x dx. And so obviously I need a 4, right? I need a 4 and I need to cancel it with a 1/4. And there it is. There's my final answer. How we doing?
Robert,
Yes.
what identity got me from cosine of 2x squared to 1 minus cosine of 4x over 2?
What line are you looking at, please?
The last two. Actually, I'm sorry, lines 5 and 6.
Yeah, so from that to that, right? Is that what you're asking?
Yes, it is.
Yeah. So cos of 2 of theta with a power reduction becomes 1 plus cos of double the angle over 2. And so if I have a 2 here, this is going to become a 4. I'm always going to double that angle.
I see. Okay.
What happened to the x over 4 that was at the beginning of line 8?
So x over 4 minus x.
Oh, right.
Yep. So 1 x over 8. Yeah.
Yep.
And I'll do that all the time. Even when I walk to my apartment, I'll skip steps. When I walk up to the 6th floor, I'll skip steps all the time. So it's easier to do it going up than down, of course. But but if I skip a step and you want to see it, I'm more than happy to do it. Okay. And usually I start to do it, and you go, oh yeah. And that's normal. Those are good things. When you don't know what happened, and then I start to show it, and you go, oh yeah, of course. That's great, right? And we have a tendency to say, okay, I get it, but then make sure you go and do it yourself, right? Make sure you go back and verify that you really do get it, right? Beautiful. So I want to stop this and let's take a 5-minute break, and then we'll do the difficult piece. Is everybody comfortable here? We did a lot of them, and I'll, it's just, you got the tricks. You know all the tricks now. So, and it's about improvising, and it's about being okay if it doesn't work out and try something else. Okay? So let's go 5 minutes. Let's meet back at 10:15. Go ahead, Charlie. Say it again.
I want to say 5.
Yeah.
You use like half angle formula, but on the previous question, if you remember on the previous one, sine square x, you use identity.
Exactly. So it's going to be one or the other.
If we use the sine square x, the same like the half angle, it would be equal answer.
Yes. And you should verify that. Do it both ways. Make sure the answers are equal.
Okay.
Yep. Good. Okay. So we'll meet back at 10:15.